This is the relationship between force and mass. FME, how does the amount of the force affect the amount of motion? In this discussion, one of the things you want to touch on with kids is the difference between mass and weight. You do not need them to completely understand it. It is a very difficult concept for kids to understand. They compared it back to you, but it is a difficult concept. Whereas mass is the amount of stuff in something, weight measures a relationship. Mass is, you can just look at something, you don't need to compare it to anything else. Whereas weight, based on how much another object pulls on it. That's why on the moon you have less weight, but the same mass. There's a video segment on this page that reviews that quickly so that the kids at least start using those terms. You don't want them to use them interchangeably. You don't want to stop instruction to correct it, but you don't want to stop instruction to enforce that they learn it, but you want to make sure they use the difference between mass and weight. And you'll be talking about mass whenever you're dealing with these physics concepts. This is just something to show you how to set this up. There's a picture on page 41. What you're doing is looking for a connection between force and motion. There are two ways you can set it up. You can put the sand in here, about halfway. Notice it is taped. Makes your life much easier. You can tape that. You will have enough of these containers to fill some half, some empty. If you're really nervous about sand, you can just put a beanbag in there for this one, and that would work as well. The picture, taking a rubber band and putting it on the bottom of a chair. Setting up rulers to measure the pullback on the rubber band, and remember we always want to use a metric, so you want to start with the 1 at the front rubber band. There are 2. When you go around the chair leg, there are 2. You want to measure everything from the front one. Unless you want to cut the rubber band and tie it to 1, but that's not worth my time. If you're really into that, go to it, but I don't expect that at all. They have their container. You want to make sure the container lid lines up with the rubber band. And then there are directions to pull this back. Pull it back 10, 15, or 20, and let it go. So they're going to line up the back, pull it back to 10, let it go. Do the same thing to 15, let it go. Now, this goggles, I believe, are noted as a safety item in this. If there is a way for children to use something to fire something across the room, they will do that. So the rule is if anything can fly, fit, go into your eye, they should be putting goggles on. Pull this back to 20, and then you let it go. You need to review those safety so they aren't taking pencils, paper clips, the smallest kid in the class, whatever it takes, to fire them across the room. There is a tape measure in there, again using metric, measuring the distance. And we're looking for a trend, and what they're inferring is as the rubber band went back farther, the container went farther, and they're inferring that the force increased. Qualitative information. Then they're given a tool, spring scale. Quantitative information. They'll put this on the rubber band, pull it back to 5, and read the newtons. Pull it back to, 10, read the newtons, 15, read the newtons, 20, read the newtons. What they should see is that at the 10 it might go down to 5 newtons, 15, and they should see a larger newton rating on the rubber band. This gives them quantitative information that the farther the rubber band went back, the greater the force. Make sense? Advanced physics stuff. You don't need to let the kids know this. Force equals ma. The mass was your constant. You did not change your mass. You did increase the force. Because of physics, what must happen? If this is the same and the force got bigger, what must occur? Just mathematically, acceleration must have increased. And you saw that. It went farther and faster. So this is getting into that idea. We're looking at how force affects motion. Good? Yes?
Does it work as well on carpet?
It will work anywhere. I've done it on carpet. On the floor, you just need to make sure you have more space. On carpet, it will work. You can talk about control variables with tape on the bottom. You notice that has a little piece of tape, and you can talk back with that infected. You know, a carpet might catch a mass versus weight. You talk about that. That mass is how much is in something. Weight is a measurement of relationship. Observation versus inference. They don't observe the force. They are inferring that the force was increased. Then they actually measure it. The qualitative observation versus the quantitative measurement. That data of newtons gives them a number that says, yes, the force was greater on the rubber band when I pulled it back farther.